Now we are starting a new chapter, mathematical reasoning, or we can say mathematical logic. So in this chapter there is a more discussion about some words which are used in language and less calculation. In this topic, in this chapter, you will not find lengthy calculation or formulas, examples, but there is discussion about like English grammar. There are so many words which we use in general practice when discussing many matters. We use some logical connectives. Because of using particular logical connectives, we can speak, we can explain whatever we want to say. We explain very clearly without any doubt. That is logic. So let us start this chapter. First topic is statement. Say many times you listen one dialogue in film or in a TV serial where court matters are discussed. Say many times you listen this dialogue in film and TV serials, as for example, a statement note किया जाए, your honor, a statement note किया जाए. So see, that judge or lawyer speaks word statement. So what means a statement? So see, the definition of statement is that a sentence is called a mathematically acceptable statement, or we can say only statement. A sentence is called a statement if it is either true or false, but not both. When a lawyer or judge says that please note this statement, a statement note किया जाए, that means whatever is discussed, whatever sentence is spoken by any party, it must be either true or false. If it is true, it is statement. If sentence spoken by any party is false, then also it is a statement. So only statements are noted in court. Means sentences, those sentences which must be either true or false. So that is the meaning of statement. Say here, which sentences are not statements? If any sentence involves question mark, then it is not a statement. Any sentence involves exclamation is not a statement. Order, request, variable time such as today, tomorrow, yesterday. So including these things, any sentence is not said to be statement. So if any sentence involves these things, then that sentence is not said to be a statement. We understand this everything in these examples. Now, whatever statements are discussed, statements are denoted by small letters P, Q, R, etc. That means label or name of statement. If any sentence is a statement, they are denoted by these symbols. For example, we denote the statement ice is always cold. Ice is always cold. This is a statement. If we denote it by P, then it is written as, put here P, statement P, which is ice is always cold. So this is the method to represent statement by notation. That means this is the label of this statement, name of this statement, statement P. P, Q, R, these symbols are used. Now question on this definition. Which of the following sentences are statement? Give reason. See, first sentence is there are 35 days in a month. There are 35 days in a month. See, this is always false sentence. This sentence is always false. So any sentence which is always false or always true is said to be statement. So this is a statement. This sentence is always a false. So it is a statement. Second sentence, mathematics is difficult. Now let me justify whether it is true or false. Mathematics is difficult. See, this is false for me because I like mathematics. For me, mathematics is easy. But this is not true. This is not true or false for everyone. This is false for me. Mathematics is difficult. That is false for me because for me, mathematics is very easy. But for others, this can be true. Those who don't like mathematics, for whom this is true. So this is not always true, not always false. Sometimes true, sometimes false. So therefore, this is not a statement. So this sentence is sometimes true, sometimes false. So it is not a statement. It must be always true, universally true, then it is statement, or universally false, then it is statement. Now here, answer this question. Answer this question, that is order. This sentence involves order. Any order is not a statement. This is not a statement. So this sentence is an order. So it is not a statement. Next is the sum of all interior angles of triangle is 180 degree. This is always true. So always true, so it is a statement. So this sentence is always true. So it is a statement. For any triangle, it is true. If I put here any other number, suppose if I give here 360, then sum of all interior angles of triangle is 360, always false. Then also it is a statement. Now here, today is Friday. If really today is Friday, on Friday, if this statement is spoken, then it is true. But if this statement is spoken on Saturday, then this is false. So this is not always true, because here this word is variable time. Variable time is used. If variable time is used in any sentence like today, tomorrow, yesterday, then that sentence is not said to be a statement. So this is not a statement. This statement, this sentence is not a statement, because variable time is used. Today is variable time. What is the capital of Sri Lanka? What is the capital of Sri Lanka? See, question mark. If any sentence involves question mark, then it is not a statement. So this is not a statement. This sentence is not a statement, because it involves question mark. What a wonderful rainbow! What a wonderful rainbow! Exclamation. See, here there is exclamation. What a wonderful rainbow! We can't say it is true or this sentence is false. For any exclamation, we cannot speak this word that this sentence is true or this is a false. So because this is exclamation, any exclamation is not said to be a statement. So this sentence is not said to be, this sentence is not statement. Because it is an exclamation. Please take rest. It's a request. And any sentence involves request, then it is not a statement. So this is also not a statement. This sentence is not a statement, because it is an request. It is a request. Any request is not a statement. So that is meaning of statement. So always remember, there is difference between these two words, sentence and statement. Whatever we speak in general practice everywhere, everything, bunch or group of words is said to be sentence, but every sentence is not statement. Statement is a sentence which can be justified whether it is always true or always false. Now next topic is negation of a statement. The denial of a statement is called the negation of the statement. Whenever we deny anything, that means negation. If P is a statement, then the negation of P is denoted by this symbol. See, this is read as not P. It is not P. Read as not P. This is not P. Negation of P. Now, examples. Write the negation of the following statements. See, Chennai is the capital of Tamil Nadu. Let me say, this is statement P. Chennai is the capital of Tamil Nadu. So negation of P is, it is denoted as not P, not P. So negation is Chennai is not the capital of Tamil Nadu. Chennai is not, means deny the statement. Chennai is not the capital of Tamil Nadu. So this is the method to use symbols. Same symbols can be used for all these statements. For statements you can use Q, so its denial is not Q. You can use R, its negation is not R. Small p, small q, small r, these symbols are used. Now here, root 2 is not a complex number, so its negation is, I am putting negation of this statement. Root 2 is not a complex number, so negation is deny this statement. It is root 2 is a complex number. Next one, the number 2 is greater than 7. Its negation is deny this statement. The number 2 is not greater than 7. The number 2 is not greater than 7. Every natural number is an integer. See, next is every member working in this office is an Indian. Look these two statements. First of all, I am discussing this statement. Every member working in this office is an Indian. See, I am taking this statement, then we will go on these mathematical statements. Every member working in this office is an Indian. Now see, I am giving simple example. So many from you watch CID crime serial, CID Pradyuman, CID team, they are working in solving various cases. Suppose CID team, Pradyuman team is going to investigate regarding any case somewhere in office where something is happened. Suppose a murder of someone has been occurred. Then what happens? Owner of office, suppose Pradyuman CID officer is asking question that are all people working in this office Indian? Then owner of office is replying that yes sir, every member working in this office is an Indian. You can see every member working in this office is an Indian. Everyone is Indian. Then what happens? Pradyuman has something doubt in his mind by observing something or observing someone in the office. Then he denies this statement. He doesn't deny this statement by this way that no, every member working in this office is not an Indian. if we insert word not, then we can feel that it is denial of this statement or negation of this statement. It's true. Denying this statement, every member working in this office is not an Indian. It's good. But to express this denial of this statement in very logical way, what Pradyuman says, he replies that no, there exists a member in this office who is not an Indian. Suppose 20 people are working in office, and if there is someone, only one man who is not Indian, then this cannot be used. Every members cannot be used. So if there exists at least one member, who is not Indian, then this is not true. So whatever reply is given by owner that every member in this office is an Indian, the reply is not true. So SCP Pradyuman denies this statement like this, that there exists, कोई तो है जो इंडियन नहीं है. Means there exists a member, at least one member, कोई एक तो है जो इंडियन नहीं है. सारे लोग इंडियन है ऐसा मत बोलो, कोई तो है जो इंडियन नहीं है. That means there exists. Now I am writing negation of this statement which is spoken by SCP Pradyuman. There exists a man, there exists a member working in this office who is not an Indian. Now after discussing this example, now coming on this mathematical statement, every natural number is an integer. Now its denial is, now negation of this statement is, or denial of this statement is, there exists a natural number, which is not an integer. So this is the way how to write denial of statements involving word every. If any statement includes word every, then putting its denial, we use word there exists. So denial of every starts by there exists. Now there exists an integer whose square is 0. Its negation is there does not exist. Here statement is there exists an integer whose square is 0. So what we say, it's a negation, there does not exist an integer whose square is 0. So that is the method to write negation of statements. Now next topic, compound statement. A compound statement is a statement which is made up of two or more statements. In this case, each statement is called a component statement. So, compound statement is a statement which is formed using more than one statements, and when more than one statements are used to form compound statement, logical connectives are used. We join component statements by and or sometimes if then. These are logical connectives. Say here, question is, find the component statements of the following compound statement and check whether they are true or false. Say here, this is compound statement. Number 3 is prime or it is odd. This compound statement is made up of two component statements, and two statements are joined by this logical connective. This is connective, connecting two statements. So component statements are let me denote them, statement P and statement Q. There are two component statements. First statement is number 3 is prime, and second is it is odd. So it is odd, that means number 3 is odd. We don't use he, she, it when we separate them into component statements. These are statements, so make it meaningful. Don't use here he, she, it. So meaning must be clear. This is number 3 is prime, this is number 3 is odd. So these are component statements. Now check whether they are true or false. See, first statement, number 3 is prime. So this is true. Here P is true. Number 3 is odd. Q is also true. Q is also true. Both are true. P and Q both are true. See here, 100 is divisible by 3, 11 and 5. So component statements are let me denote them by P, Q and R. Component statements included in this compound statement. First component statement is 100 is divisible by 3. Second is 100 is divisible by 11. And third statement is 100 is divisible by 5. So there are three component statements which are included in this component in this compound statement. 100 is divisible by 3, 100 is divisible by 11, 100 is divisible by 5, and these are connected by word and. Here logical connective was or, here logical connective is and. So these are logical connectives, or and these connectives are used, we use these two connectives maximum times in every language. Now see, in this question, statement P, 100 is divisible by 3, this is false. Here P is false. Q is also false. Q is false, or 100 is divisible by 5, R is true. P is false, Q is false, but statement R is true. So if you check truthness, this is false, this is false, this is true. Any one component statement is true. So what is the truthness of this compound statement? 100 is divisible by 3, 11 and 5. So what can be said about truthness of this compound statement? So this given compound statement, it is false. Given compound statement is false. Here, given compound statement is false because here these component statements are connected by AND. When component statements are connected by AND, then to be compound statement true, all component statements must be true. So remember, if all component statements are true, then and only then compound statement is true. But if any one component statement is false, others are true. Say here, this is true, these are false. If at least one component statement is false, then compound statement is false. So that statement I am putting here. If all component statements of given compound statement are true, then given compound statement is true, otherwise it is false. So here compound statement is false. So this was about truthness of compound statement when it is connected by word AND. So we can prepare truth table for the compound statements in which AND is used. For that, we can remember this statements by this way, that P and Q, this compound statement we denote, this is denoted by P and Q. This is read as AND, P and Q. So P and Q, it is read as P and Q. Now here I am putting truth table. P, Q, this is read as P and Q. Now you can remember this truth table by this way, that say whenever any two statements P and Q, component statements, are given, if both statements are true, both are true, all component statements of given compound statement are true, then given compound statement is true, then this is true. But if P is true, Q is false. If Q is true, P is false. Or if both are false, then P and Q, this is what? P and Q. This type of compound statement is false. So here AND is used as logical connective. Now, sometimes in some of the statements, AND is not used as logical connective. As for example, sometimes AND word is not used as logical connective or connective. As for example, we consider statement that mixture of honey and haldi, mixture of honey and haldi is effective to cure cough. Observe this statement. Mixture of honey and haldi is effective to cure cough. But look, here AND is not used as logical connective, because here from these statements we cannot find two component statements. If you try to find component statements, then what happens? See, mixture of honey is effective to cure cough. Meaningless statement. Mixture of honey is effective to cure cough. Mixture of haldi is effective to cure cough. That is meaningless. So here the talk is about mixture. So without this word AND, this statement is meaningless. So this statement is not compound statement. This statement is not compound statement. So remember, every statement having word AND cannot be compound statement. Sometimes this happens. There are some statements which are having word AND, but they are not compound statement, because from such statements component statements cannot be separated. Now we are discussing use of word OR, connective OR. Say here exclusive OR, if OR is used in exclusive sense or inclusive sense. Now what means exclusive, inclusive? To understand this, taking example, look this compound statement. After passing higher secondary examination, students take admission in engineering colleges or in medical colleges. So here I am separating component statements. Let me take statement P. Statement P is after passing higher secondary examination, students take admission in engineering colleges. Or now OR separates this compound statement in two parts. Let me say second component statement is Q. Q is after passing higher secondary exam, students take admission in medical colleges. So there are two component statements in this compound statement having a connective OR. Now look here, whenever any student takes admission, then either he takes in engineering college or he takes in medical college. Admission in both colleges at a time is not possible. Occurrence of event P and event Q is not possible. Here, occurrence of event P, occurrence of event P and event Q at the same time is not possible. So, if occurrence of two events not possible at the same time, then here OR is said to be used as exclusive OR. So here word OR is used as exclusive OR. When this happens, OR is said to be used as exclusive OR. Say in this example, what means inclusive OR? School is closed if it is a holiday or a Sunday. Here OR is used as connective. It separates the two component statements. So here I am putting component statements. Let me say first statement P is the school is closed. School is closed if it is a holiday. Second statement Q, the school is closed. So in second part we can't use it is closed, that is not allowed. The school is closed. School is closed if it is a Sunday. These are two events. School is closed on holiday or on Sunday. Now say, many times it happens that a holiday is on Sunday. So both events can occur together. In this question, in this example, occurrence of both events was not possible, but here it is possible. Say here, because holiday can be on Sunday. So occurrence of both events P and Q at the same time is possible. So that's why this OR is, therefore here OR is said to be used as inclusive OR. Inclusive, in means occurrence together. Exclusive, that means do not occur together. Now look two more examples on exclusive inclusive. To apply for a driving license, you should have a ration card or passport. Imagine two component statements. First statement is, to apply for a driving license, you should have a ration card. Second statement is component statement. To apply for a driving license, you should have passport. In statement P, ration card. In statement Q, passport. Now, many of us may have both ration card as well as passport. Many persons may have both cards. So, inclusive. So, here having both cards at a time, having both cards to any person, to many persons is possible, means occurrence of both event possible. So here or is used as inclusive or. Say here, all integers are positive or negative. All integers are positive, that is first part. Then this is connective. All integers are negative, that is second part. But all integers having both signs positive, negative at the same time, it is not possible. So occurrence of both events at a time is not possible. As for example, as we discussed here, student can't take admission in both engineering and medical. Similarly, any integer cannot have both sign positive and negative. So here occurrence of both event is not possible. Here any integer cannot have both signs positive and negative at a time. So here or is, therefore or is used as exclusive or. So that is about use of or.